Good evening friends, this is Professor Vishal. In today's session we are going to discuss about the empirical formula and molecular formula. Okay, in last lecture we started how to write down the empirical formula for given compound. Now in today's session we are going to discuss about the molecular formula with one practical example. Okay, so in general in last session I discussed one in general example with you all. Now in today's session we will continue this empirical formula, how to write down the empirical formula, then based on that empirical formula how to write down the molecular formula. So we will take one example through which you are going to understand. So question is like this: molecular mass of organic compound is 78. I am directly write down here. So empirical formula and molecular formula. Okay, so we started this. I gave here in last session one example which contains variable, but in today's session we are going to discuss one practical example. Okay, so the question is like this: molecular mass of organic compound is 78. Molecular mass is 78, it is given, and its combination is given as 92.4% carbon is there. Okay, and hydrogen is 7.6%. Had 7.6% hydrogen. Okay, so as we already discussed, we have to form one table here, so which consists of 5 to 6 columns. Let us say first column is of serial number, the second is of that particular elements, third percentage, so fourth one is number of moles, then fifth and sixth. Okay, so we will see here we are having two elements. Okay, first one is carbon and second one is hydrogen. So I am taking first as a carbon element whose percent is given as 92.4. second one is hydrogen, isn't it, whose percent is given as 7.6. Now how to calculate the number of moles? Number of moles are nothing but the percentage divided by molecular mass. So here, or atomic mass, sorry, percentage divided by atomic mass. So this is how to calculate the number of moles, percentage divided by atomic mass. So likewise, if we use this formula, I will complete this table. Okay, so here I will get 92.4 as a percentage divided by, and atomic mass of carbon is 12, so it is 12. Okay, similarly for hydrogen it is 7.6 and atomic mass is 1. Okay, so if I will calculate it, what I will get, 92.4 divided by 12, it is nothing but 7.7. okay, so after this it becomes 7.6. okay, so in last lecture we have already discussed select minimum value out of these two. Here in this case minimum value is 7.6, so we have to divide with this minimum value to both terms. Okay, now what I will do, I will divide this 7.6 divided by 7.6, 7.7 divided by 7.6, and then itself 7.6 by 7.6. okay, so whatever the answer I will get, I have to write down here. So 7.7 divided by 7.6 is nothing but 1 point something, or we can say it is 1. Okay, so more or less it is 1. For 7.6 and 7.6 it is perfect 1. It is more than 1, slightly more than 1, I can take it as a 1. Okay, by considering rounding off principle. Then based on this answer, I can write down the empirical formula as C1H1. Okay, so up to this we have seen. So this is practical example I am discussing about here, in which 92.4% of carbon is given to you, 7.6% of hydrogen is given to you. So we have to draw one table which consists of serial number, columns like serial number, elements, percentage, number of moles, and here you will get answer. Okay, so here I just put at the elements of carbon and hydrogen, that is given in the numerical. So it is percentage is also mentioned, 92.4 of carbon, 7.6% of hydrogen is there. So I will calculate number of moles, percentage divided by atomic mass, percentage is 92.4 divided by 12. Okay, here also 7.6 divided by 1. So I will get 7.7 and 7.6. Okay, so here what I will do, I just have to identify the minimum value out of these two and divide this with this minimum value to both terms. So it is observed that 7.6 is the minimum, so I divide it by 7.6 to both terms, so it becomes 1 point something, and by rounding of principle I will get this as 1, and also it by default it is 1. Okay, so I can write based on these values C1 and H1. Okay, this is your empirical formula. Okay, now next, how to calculate the second term, that is molecular formula. So basically formula, to write down the molecular formula is, or molecular formula can be written as N into empirical formula. Okay, means what? If I want to calculate the molecular formula, I know empirical formula. Okay, and let us see what this N means exactly. Okay, so I will rub it again. Now most important thing we have to consider it is C1H1. Okay, so I will write it down. C1H1 is empirical formula right now, what I am getting. So I have to put here. So I will rub it. So this is the way you can calculate the empirical formula, because without knowing empirical formula you cannot write molecular formula, isn't it? So next is, as per the formula of molecular formula, as per the formula to calculate this molecular formula, N into empirical formula. Okay, I am having empirical formula with me. Just if I know N, I can easily write down the molecular formula. So what do you mean by N? So N is nothing but the index to write down the molecular formula simply. So it is the ratio of molecular mass upon empirical formula mass. Molecular mass upon empirical formula mass. Okay. Now question arises, what is molecular mass? So if you read the question carefully, molecular mass of organic compound is already given, which is 78. It is given in problem. Okay. Now remaining thing is what is empirical formula mass? Empirical formula mass is nothing but molecular mass of empirical formula, which I wrote it down, isn't it? So I will quickly revise this, or I will write down how to calculate this empirical formula mass. Empirical formula mass. Empirical formula is C1H1. So I just have to put the values. Okay, so carbon present in is only one atom, so it becomes 12, plus hydrogen is also 1, so it becomes 13. Means what? You have to calculate the molecular mass of the particular empirical formula. That gives me empirical formula mass. Okay, so here I will repeat. In order to write down the molecular formula, I have to use this, okay, equation, we can say N into empirical formula. Okay, so empirical formula is with me, and I just want to know what do you mean by N. So N is what? N is the molecular formula index, which is equal to molecular mass divided by empirical formula mass. So molecular mass is given in problem as 78, and empirical formula mass is calculated in this way. Empirical formula mass is nothing but molecular mass of this particular formula, okay, which I formulate, for which again I need empirical formula. Now here, once you will get this as value as 13, I will put this value here. Okay, so 13 was a 13, 13 6 is a 78, so it becomes 6. So value of N I got is 6. Now just put the value here, it becomes 6 into C1H1. So finally molecular formula becomes C6H6. So this is how you can calculate the you can write down the molecular formula of a given compound. Okay, first important thing, you have to write down the empirical formula. Now most of the time students will confuse, sir, you just wrote here empirical formula, then put the value of, calculate the value of N, and for which you need empirical formula mass, so you calculated in between. So this is for your understanding. Okay, now I will let you know how to write down the problem in your examination, how to write down the answer of such problems according to steps. First thing, Up to empirical formula, you have to use as usual steps. Just draw one table and formulate the answer. You will get empirical formula. Once you will get empirical formula, first and important thing, you have to calculate empirical formula mass at that time. Okay, so that is this step. Once you will get empirical formula mass, molecular mass is given in your problem. Use this formula. After empirical formula, this is your first step. Okay, so this becomes your second step, isn't it? So n equal to molecular mass upon empirical formula mass. Now both values are with us, so I can calculate n as 6, and this will be your third step. So this third step gives you molecular formula of the particular compound. Okay, so in this way you have to solve this problem. But before this, one more note is there, or important point is there. Sometimes what will happen, instead of this molecular mass, then another term is given, so that term is known as vapor density. Instead of molecular mass in problem, vapor density is given. Okay, then in order to calculate the molecular mass from vapor density, we have to multiply it by 2. Means let us say vapor density is of a compound is given as 10. So molecular mass is nothing but 2 into that vapor density. Okay, so that gives me molecular mass. Simply we have to multiply it by 2 when the vapor density is given. Okay, so that is all about molecular formula. Okay, so in this way I thought it is clear to you all how to write down the empirical formula. Based on empirical formula, how to write down the molecular formula. Okay, now you will see one more example. So here if you see, you will come to know in this example there are 2 elements only. Now what will happen when 3 elements are there? Okay, so let's see with the help of one example. So in this example I am discussing about introducing the term vapor density, as I already discussed. Okay, problem is like this. Vapor density of organic compound. Second question is like this. Vapor density of compound is 83. Carbon percentage is given as 57.8. Carbon is given as 57.8 percentage. Hydrogen is given as 3.6 percentage. Okay, and oxygen we have to calculate. Oxygen we have to calculate in this formula. Okay, so if we remember the latest term, percentage combination, oxygen we have to calculate. Okay, so here if you see, this compound consists of 3 elements, carbon, hydrogen and oxygen. Out of these 3, percentage of 2 elements are given, third is not given, and instead of molecular mass, vapor density is given. Okay, so simply first and most important thing is what, when 2% in, we have studied in percentage combination, when 3 elements are there, and out of these 3 we will get, if we have percentage combination of 2 elements, we can easily calculate the percentage of third element in the given compound. Okay, so simply percentage of oxygen, so from here your answer is started, equal to 100 minus percentage of carbon plus percentage of hydrogen. So it becomes 100 minus, it is given as 57.8 plus 3.6. Okay, so if I will add them, I will get 8, 6, 14, 4 is remaining, 1 is remaining, 11 and 6, so it becomes 61.4. Okay, so if I will subtract it, I will get this answer as a 38.6. So I can say that in this given compound, oxygen is present, or percentage combination or percentage of oxygen in the given element is, given compound is 38.6%. Okay, so this is how you have to calculate the oxygen. Okay, now you have to follow the regular procedure. That is, firstly draw the table, calculate, write down the empirical formula, then based on that write down the molecular formula. Okay, so let us start with this. First, before proceeding, you must know, if problem is like this, if 3 elements are given in a compound, you have to calculate first percentage of the element which is not given in the question. Okay, so once it will end, we will start with our how to write down the empirical formula for this problem. Okay, so I will rub it. Okay, in this way you can calculate the percentage of oxygen. So here I will make one table, as usual table as we already discussed. First column is of serial number, second is of elements, third one is, now we can write down here answer. It is 38.6, isn't it? So I calculated it, so I will write down here 38.6 is the answer of oxygen, first one. Then percentage, then number of moles, it is calculated by percentage upon atomic mass, isn't it? So then, so here within 2 to 3 columns you will get answer. You just write down the answers and you will get here combination and empirical formula. Okay, so we complete this. So this is for, let us say, first element, this is for second element, and last one is for third element, let us say. Okay, 1, 2 and 3. So the element first is given as carbon, so I just wrote down here. Second is hydrogen and third is oxygen. Okay, so now here carbon percentage is already given 57.8, hydrogen is 3.6, and oxygen we latest calculated it as 38.6. Okay, now calculate number of moles. Percentage is 57.8, atomic mass is 12. 57.8 divided by 12, so it becomes 4.82. Okay, next 3.6 divided by 1 itself, it is 3.6. Okay, then 38.6 divided by 60, it is also 2 point something, 2.41. Okay, now after this, next step is what? We have to identify minimum value out of these three and divide with this minimum value to the all three terms. Okay, in this particular table. So if we observe, out of these three, minimum value is 2.41. So what I will do, I will divide these three values by 2.41. So when I will divide this 2.41, I have to divide it by 2.41, and again I have to divide it by 2.41. Okay, so this answer is nothing but something in terms of 2 4s are approximately, and again I am using rounding off principle. So if we calculate it, it becomes 1.5, isn't it? 2 and 3, I am considering these two terms only initially, so I can guess the answer easily. Okay, then it becomes 1. Okay, so this is how you will get your answer. Generally what we did in previous problem, I just wrote down the C2H1.5 and O1 here, but here if you see, this is not a, this is the answer which we get for percentage or element hydrogen is in fraction form. We have to convert it in complete whole number. So what I will do, I will just it multiplied by 2, isn't it? So I have to multiply each elements by 2. So 2 into 2, 1.5 into 2, and 1 into 2. So that gives me answer 4, 3 and 2. So in this way I can get this answer 4, 3 and 2 means what? Empirical formula equal to C4H3 and O2. So this is how you have to write down the empirical formula. Okay, C4H3O2. So this will gives you the empirical formula. Okay. Now once you will get empirical formula, next step, next target is to write down the molecular formula. Okay, so I hope it will understand to you. If you understand it, just look at it and you can take a snapshot. I will proceed for molecular formula after. Okay. Now here I already told you, in order to calculate the molecular formula, we must know molecular mass, isn't it? If molecular mass is not given, they will provide us vapor density like it is given in this problem. Vapor density of a compound is 83. Just we have to multiply it by 2, it will give you the molecular mass. Okay. Then you have to find out the empirical formula mass. After that, once you will get molecular mass and empirical formula mass, this ratio of molecular mass divided by empirical formula mass gives me molecular formula index, and when I will multiply this index with this empirical formula, I will get molecular formula. Okay, so let's start this. this answer here, because empirical formula is with us right now, C4H3 and O2. Okay, so first step, as I already discussed with you all, so first step here is to calculate empirical formula mass. Empirical formula mass. So empirical formula mass is nothing but molecular mass. Simply we have to calculate molecular mass. So if we see 4 atoms of carbon, so 4 into 12, then plus 1 atom of 3 atoms of hydrogen, molecular atomic mass is 1, and plus 2 atoms of oxygen, so 2 into 16. So if I will multiply it, 48, 3 plus 32, so it becomes 51, 61, 71, 81 and 83, isn't it? So it is nothing but 83. I can write down the empirical formula mass is found to be 83 units. Okay, now once you will get empirical formula mass, you have to calculate the molecular mass. So again I will repeat, molecular, either this term is given in your problem, or if this term is not given, they will provide vapor density. Okay, so in order to calculate molecular mass from vapor density, we have to multiply it by 2 into vapor density. 2 into vapor density. So it becomes 2 into 83. So it becomes 2 is a 6 and 2 8 is a 60. So it is 166. Now third step is to calculate this index, n equal to molecular mass divided by empirical formula mass. Okay, so it is molecular formula mass is 166, empirical formula mass is 83. Okay, it is very simple. 83 1 the 83, 83 is a 166. So what I will get index as a 2. Okay, now once I will get index, next step, that is fourth step, is I'm just writing it down at this position. Okay, so next step, that is step number 4, molecular formula equal to n into empirical formula. Okay, so now here we will get this n as a 2, isn't it? So just put the value of 2, and empirical formula is with us. It is found to be C6H3 and O2, isn't it? C6H3 and O2. Sorry, C4, it is not C6. C4H3 and O2. So just it becomes, when I will multiply this index by each term, C8, it becomes H6 and it becomes O4. So this is how you will get molecular formula. Molecular formula is nothing but C8H6O4. So I can write collectively empirical formula equal to C4H3 and O2, and molecular formula equal to C8H6 and O4. So these are nothing but your two answers. So in this way you can write down these two formulas, which is most important. Okay, so here again I will repeat shortly. Once you will get empirical formula, first step you have to calculate empirical formula mass, then you have to calculate molecular mass, either it is given or it is given in terms of vapor density, like this problem. When it is given in terms of vapor density, you have to multiply the vapor density by 2, constant 2. You will get molecular mass, and then once you will get molecular mass, you can calculate value of n, that is molecular mass divided by empirical formula mass. And once you will get n, you have to put the value of n here, use this formula, n into empirical formula. So here 2 into C4H3O2, this is what I got empirical formula in previous step. I calculated it, I wrote it down. So C8H6 and O4 is nothing but the molecular formula. So this is how you can write down these two important formulas. Okay, so after that we are going to discuss about stoichiometry of chemical reactions. Okay.